Hello everyone. In today's video, we have to solve the minimum number of operations to make elements in array distinct. So let's understand the problem. So the problem is that you are given a list of integers and there can be duplicates in it. And your goal is to return a list which has only the unique integers. And only operation you can perform is that you can chop out or remove first three elements from the list. You are not allowed to change the order of any elements. So let's see one example. Here we have 1, 2, 3, 4, 2. So 2 you can straight away see that there is a repetition. 3 is also repeated 2 times and the other ones are okay. So let's see how we can do it. So let's take this same example. So here first you can do is that you can keep track of the count and or not the count, last occurrence of any number. So these are the indices 0, 1, 2, 3, 4, 5, 6, 7, 8. So you know that only the final list will have some list, same list from let's say index k to n. So last n minus k plus 1 elements will remain same. Only thing is that you had chopped some elements from the beginning and that should be some multiple of 3. You will not chop one element, but you have to chop 3 at a time. So you will see that where the last duplicate occurs. So you see that if you look at this 3, clearly there's one more 3. So last duplicate or rather you are interested in second last duplicate because last duplicate, if you chop till second last duplicate, there are let's say 5. 5 occurs 4 times. And this is the last position where 5 occurs and there are more elements. Let's say these are unique. So this is the second last occurrence of 5. So if you chop till this point, there will be only one occurrence of 5 remaining. So it will be unique. So till these are already unique, this also becomes unique. So we are interested in second last occurrence of duplicate elements. And we are not worried about unique elements. We will only keep track of which elements are duplicated and what is their second last occurrence. And you can only chop from index 0 to some index, let's say k minus 1, and this is k to n is already unique. And you have to do in batches of 3. So one thing is that if there are less than 2 elements, no need, already it will be unique. And also it's given that empty list is, you can consider that as unique. So now, how do we find the last occurrence of any duplicate? So you can keep track of which elements are there. 1 occurs at 1 at position 0, 2 occurs at position 1. So we see that whether it's in our hash map or not. So when we insert 1, we see that this is the first time we are inserting. So there is no case of duplication. When we find 2, we check whether 2 is there or not. It's not there. So we record its index. 3, again a new element. 4, again a new element. Then we get 2. So 2 we see that it's already here. So now this is the first time we are encountering a duplicate. And then the new position is 4. So we can keep track of what was the uh, maximum duplicate index we can keep track of. Let's initialize to -1. So when we traverse the entire list and we don't, if it remains -1, then we know that there were no duplicates. So we will return 0 operations. So here we have to return how many operations we need to do. And there is only one operation, that is removing first 3 elements. So we will return 0. So here we found encountered duplicate. So we store the second last. So we saw why we need the second last, so that whatever is the largest second last value of any duplicate, we have to chop all the elements till that. So that's why uh, we will keep track of that. So we encounter this duplicate 2. So now we know that second last duplicate is So we had 2 at position 1 and now 2 is at position 4. So second last is 1, which is more than this. So we update this value to 1 and we update this value, we replace it. We just keep the last occurrence. And before saving the last occurrence, we save the second last occurrence in this variable. And this will be largest for any duplicate. Next we encounter 3. We see that 3 is already there. So 3 was already at position 2. Now 3 is at position 5. So we see what was the second last occurrence. This is the last occurrence so far. So second last occurrence was 2, which is more than 1. So update this variable to 2 and store here the latest one, 5. So that next time we encounter any duplicate, this will become the second last and we will store that value here. So far so good. And then we again find a 3. So we see that 3 is in the map and its occurrence, previous occurrence was 5. So we store the previous occurrence 5, which is larger than this, obviously. So now this max duplicate index is 5 and we store 6 here. Then we encounter 5. 5 is not present. So we store 5 at position 7. Then we go to 7. 7 is not there at position 8. So we reach the end of this list. So the maximum index till we have duplicate is 5. So till here. So we have to remove till here. So how many elements are there? So index is 5 and it starts from 0. So 0 to 5 there are 6 elements. So we need to remove first 3 elements and then again next 3 elements, and now everything is unique. So we will return 2 in this case. Similarly, if we had the index was let's say remains -1, then we know that there were no duplicates, so we will return 0 in that case. Let's here it's perfect multiple of 3, but we are only allowed in multiples of 3. Let's say this index was 6 instead of 5. So we know that there are 7 elements we need to remove. So that will need 3 operations. So 3 elements, again next 3 elements, and again next 3 elements. So 7 elements will remove with third operation. So if there are only 2 elements, then count that as 1. So that is a special case. So if the index was 6, we would have returned 3. So what is the time complexity? It's O of n. We are just scanning this list once in a space. We are storing all the elements in the map and one corresponding value, no vector. We are not storing all the indices, just the last index. So space is also on, time is also in. So now let's write the code for this. So first let's save the size into num dot size into n. So if n is less than 2, return 0, and we will keep track of last duplicate index, and it's -1, and then unordered map of int and int, let's call it chars, and then we iterate through this list. So if chars, if the number already exists in chars, then so if count is 0, then that means it exists in the chars. Then we will see last duplicate index equal to max of last duplicate index and chars nums I. And then we discard that value and add the latest value into it. And then we are done. We will check if this is equal to -1. That means No duplicates were present, so 0 operations are required, else we return last duplicate index divided by 3 plus 1. Because if the index is 5, uh, we have to return 2. If index is 6, we have to return 3. If index is 7, then also we have to return 3. Index is 8, then also we have to return 3, because till index 8 it's 9 elements. So from 6 to 8 the value will be 2 point something. So if this is integer division, so just 2, but actually we need 3. So plus 1 in the end, will you can verify that, and let's run it. So it passes the 3 test cases. Let's submit, and the solution is accepted. So I hope you understood this. So see you in the next video.